Alright, this is going to be part 2, which focuses on converting from rectangular to polar form, and also the multiplication, division, addition, and subtraction of complex numbers. So if we look at the general formula or equation for rectangular form, we have z is equals to a plus jb, a which represents the real number, jb which represents the imaginary number, and then the whole thing is called a rectangular form. And then since we're gonna be converting from rectangular to polar, then this is the general equation that we use for a polar form. So this is a polar form. So before we can look at the whole process that one must take in order to convert from rectangular to polar, let's first look at the Cartesian plane, or what we call an Argand diagram. So we know for a fact that a Cartesian plane has the y-axis and also the x-axis. This is the positive x-axis, positive y-axis, negative y-axis, negative x-axis, negative y-axis. Okay, so now I need to let me write a complex number in a rectangular form. Let's say I have z is equals to, let's say, positive 3 plus 4j. So now, why am I writing this? So along the x-axis, I can simply draw the real number. So this could represent the real numbers on the x-axis, real numbers. And then on the y-axis, then we could literally have the imaginary number. Imaginary number, right? So since, well, I'm gonna be looking at 3 plus 4j, how can I plot this imaginary number on the Argand diagram? So 3 units, if I count, if this is 0, from 0, 1, 2, and then 3, if 3 units is at this place, then it's a showcase. Then I'm going to have a ruler and then draw that going up, and then make sure that 4 units going up, it's positive. Then 1, 2, 3, 4. So 4 will be somewhere there, and then where these two meet, then I'm going to draw a point, right? So now, what is it that I can do? I can literally construct a triangle, meaning if I draw a vertical line from that point to the unit 3 going down, and this vertical line is actually 90 degrees. 90 degrees to the horizontal axis, then I'd have something of this nature. And then if I draw a line from the 0 point to that point, then I'd have something of this nature, which is, you can clearly see that we have a right angle triangle, and which actually brings us to a point where we want to label. You know that this is if you have an angle here between the x-axis and the hypotenuse, then we call this side an adjacent side, and then this is the opposite side if the angle theta is situated at that point. So we have opposite here, opposite, and then we also have adjacent here, adjacent, and then we also have the hypotenuse, But since where we are dealing with complex numbers, the names are slightly different. I'm not going to be calling a hypotenuse a hypotenuse. So now, okay, let's talk about the names. Let's say a different name that we assign to hypotenuse. Hypotenuse. We can say this is the modulus. And then we can also use a symbol small r, right? Now that's that. And then since we have a right angle triangle, then it's a showcase that we can apply theorem of Pythagoras. So we know that Pythagoras, if we apply Pythagoras here, then we know that r, or the hypotenuse, or the modulus small r, which is the squared, is the same as x squared plus y squared, right? So since I'll be looking for, let's say, r in this case. Remember that already from the rectangular form, we do have the x, form of real number, and then we do have the y, which is 4. So we can literally substitute what we have. So we have 3 squared plus y, which is 4 in this case, but we don't have the hypotenuse. We don't have that distance. So you can just say, okay, r is introduce the square root on both sides, and then just so you can get rid of that squared, then it becomes something of this nature. And then you know that 3 squared plus 4 squared, then the whole thing is going to give you 25. So the root of 25 is going to be 5. So this is what we call the modulus, or the r, or we can say the hypotenuse, right? So now, once you look at the modulus that we got, it goes straight to the general formula of the polar form. It goes straight to this. But then now, as you can see, remember that I'm just gonna write it down. Z is the same as r angle theta. So we just found r to be 5, right? So how do we then go and calculate theta? So since we have ourselves a right angle triangle, then we are welcome to use our trig ratios, which is you have SAW, CA, and 12. So if I'm going to rely on what we had initially, which is x and y, or the opposite and then the adjacent, then it's a showcase that I can rely on 10, which is the adjacent, or the opposite, which is opposite divided by adjacent. So that's going to be the 10 of theta is the same as what? Opposite, which is it's y over x. And then you know for a fact that I'm looking for theta, that's going to be theta, and then 10 inverse y, that's going to be 4. Remember that y is going to be 4, and then your x is going to be 3. And the whole thing, when you punch that to your calculator, you're going to get 53,13 degrees. So that's theta. Now you can say you've managed to convert a rectangular form, which was 3 plus 4j, to a polar form, which is now it's going to be z. It's the same as what's r? R is 5, and then theta is going to be 53,13 degrees. This is now the polar form. But then remember this is the longest way of doing things. You can just quickly punch it into your calculator and get a polar form. So all right, but if we can convert from rectangular to polar, then we can convert from polar to rectangular. So how do we go about that? All right, so if we have the very same polar form and then we want to take it to rectangular form, then going back to the Argand diagram, then we do have the modulus and then we do have the angle. So remember that the angle itself, it's also called the argument in this case. So we do have these two properties, but then we do not have A, we do not have B. So how can we find A and B? If we incorporate trig ratios, sine, so so it's quite evident that if we focus on sine, which is the opposite, and the hypotenuse, then we can get B. So if you write the sine of theta, it's going to be the opposite. In this case, it's going to be B over R. R for hypotenuse, or the modulus, and then sine of theta. In this case, we have 53 comma 13, which is the same as B. We do not have B, and then R, we do have that to be 5. If we cross multiply, then we find that B is the same as 5 sine 53 comma 13, right? And then we do the same for A, and then we'd say A is going to be the cos of theta, which is the same as adjacent for A, all divided by R, which is the hypotenuse. And then find out that cos of theta, which is 53 comma 13, is the same as A. We do not have that. And then R, which is the number 5, then A would be 5 cos of 53 comma 13, right? That's how you can solve this problem. So that is to say, the very same polar form, which is 5 angle 53 comma 13, it would be the same as if you take A, which is the cos, and then BJ. Remember the general equation, it has A, the general equation for a polar form. For a rectangular form is going to be A plus BJ. So A, which is 5 cos of 53, is going to be 5 cos of 53 comma 13 plus J, which is going to be outside, 5 sine of 53 comma 13. If you could go and punch that in a calculator, then you'd get the very same answer that we got previously, 3 plus 4J. That's that. So if you want to convert to a rectangular form, then you'd say Z is the same as R cos of theta plus J and R sine theta. This is now the general equation. If you want to move from polar to rectangular, you'd use this one. So that's that. And then, yeah, I want you to try this. I want you to try this. Please try this. you have yourself z number 1, z equals to negative 2 plus 3j. And then second one, you have z equals to negative 4. No, it's just 4 minus j. And then lastly, we have z equals to negative root 2 minus root 3j. So please try this one out. You just have to convert from rectangular to polar form. Yeah. Now I want us to look at the third part, which is the addition, subtraction, multiplication, division, and powers of j. So in this case, I'm just gonna do one example just so we could see how to actually add. So let's say example number 1, this is what I have. I have z1. Remember that I'm given z1 to be 4 minus 2j, and then the second rectangular form, which is negative 3 plus 7j, and then the third one is 5 minus j, right? So if I was required to add z2 and z1, this is how I would do it. So z2, which is negative, let's just say negative 3 plus 7j, can just put it in brackets, and then plus 4 minus 2j. So here you just have to add like terms. Negative 3, if you add negative 3 with a positive 4, and then you're going to get 1, and then j, 7 minus 2, that's going to be a 5j. That's how you'd actually add. You add real numbers with real number, imaginary number with an imaginary number. That's it. This is the answer. Same applies. Let's say if you have now, if you had to subtract z3 and z2, so z3, which is going to be 5 minus j minus z2 minus 3 plus 7j sharp. So now let's first try to get rid of this, and negative, this is going to be plus 3 minus 7, right? And then 5 minus j. So 5 plus 3, that's going to be 8. And then what did I do here? I just forgot to write j. And then minus j minus 7, that's going to be a minus 8j. So this is the answer if you had to subtract. Now if you had z1 multiplied by z2, and you know that z1 is going to be 4 minus 2j, then you can just put the brackets. z2 is going to be minus 3 plus 7j, right? So in this case, how are you going to multiply this 2? So let's see. If you have 4 times that, you're going to get minus 12, right? And then 4 multiplied by the same way that we use a FOIL method. So if you times 4 and that, you're going to get, let's say it's going to be that's 28 28j, and then we have negative 2 multiplied with that negative, and negative is going to be positive, and then you have 2 times that is going to be 6j, and then lastly you have negative 2 and 7, which is going to be minus 14j squared, right? So now let's see now you have minus 12, just gonna drop it as it is, and then you have like terms here 28 and 6, that's going to be 34, that's going to be 34j. And then now let's look at this minus 14j. So it's more like you have here, you have yourself j to that j squared. So how do you then resolve this? You have j squared. Remember, j represents what? J represents the root of -1. So everything, this is going to be now minus 14, and then remember here it's negative root, the root of -1 squared, and then you have 34 here, j, and plus minus 12. So a root of -1, if you were to punch it in your calculator, you find that no, the answer to that it's going to be, if you multiply, let's get rid of minus 12 plus 34j minus 14, right? So remember that if you take that square root, it's the same as 1 over 2 multiplied by 2. So 2 and 2 will cancel each other out. Hence, if you now, you're going to be left with -1 multiplied by -14, which is going to be 14, and then positive 14. Yes, let's just say 12 plus 3j, and then now we're going to have 14 here. So -12 and 14, those are the two like terms, so it's more like 14 minus 12, so you're going to be left with 2. So it's going to be 2 plus 3j. This is the final answer. That's the final answer. So that's how you actually add. That's how you add. That's how you subtract and you multiply. I need to do division. I need to do division and powers. So that would be on the next video.